Good morning, everybody. And yep, as most of y'all have done, please remember to sign into the chat. All right, so I guess we will go ahead and jump in. So we've been talking about vectors. We talked about what they are, what they require, and we started talking about what we can do with them, how to add and subtract them. We talked about multiplying by what is called a scalar in order to scale the vectors. We talked about all of this, I guess I would say graphically, what it looks like to actually do it to the arrows themselves. Now we're going to get more into what these things mean when we do them algebraically. So first, I guess we will go with vector addition. Okay. So remember, there were two kind of camps of, or two different ways to talk about a vector. We had a talk about the vector's magnitude and direction, but then we also talked about it with component form. And component form is how we generally do most of our math with this stuff, because it's very kind of simple, straightforward, but it is a little bit confusing. For most people, vectors are this wild, mystical thing, and they really shouldn't be. it's just like anything else we've dealt with. A good example is polynomials, okay? So when adding two polynomials together, we'll say these two polynomials. I want to add these two things together, okay? What do I get?
Would you get 4x squared plus 2 minus 2?
4x squared
Plus 2x, I'm sorry.
Yep, plus 2x
Plus 2.
plus 2. Yes. How did you know that?
Just combining like terms.
Just combining like terms. Exactly right. So one of the ideas behind this is that like terms are kind of their own dimensions. So if x has a unit to it, let's say meter or feet, then this thing has square feet as a unit because it's feet squared. This thing has just feet as a unit, and this thing doesn't have any units at all. So when you go to add these things together, like we've talked about in the past, you can't add things with different units. So you can only add the x squareds together. You can only add the x's together. And you can only add the non-unit ones, we'll say, together. In the exact same way, when you add vectors, their directions are, or their components are separate, they're independent. So you can only add x's together, and you can only add the y's together. So remember the way it works for component form is like this. So whenever I do the bracket, the x component is the first one and the y component is the second one. Just like if you're talking about points, the x is the first one and the y is the second one. So let's say we have two vectors. Let's say vector A equals 3, 4. Vector B equals, give me two numbers between -5 and 5.
-3 and 4.
-3, 4. Okay. Well, what is A plus B?
Are you saying like 3 and 4 plus -3 and 4?
Yeah, what is this plus this?
0.
So 3 plus -3 is 0. What about 4 plus 4?
8.
8. So when you add two vectors algebraically, you just add the components. And you add the two x's, and it becomes the new x. You add the two y's, and it becomes the new y. It's part of the reason I like this framework is because you just add them by stacking them on top, and all the ones in this column together, all the ones in this column together. So if you did it like that, so it really is that simple. You add vectors and you just add up the components. Well, let's look at that for a second graphically, just to make sure that it meshes. So we have a graph, and we're going to go 3 to the right and 4 up, which will give us A. So that one. So 3 to the right and 4 up. AX, AY. So A looks like that. Then to add B, which is 3 to the left, and 4 up, so visually, A would be this black one, B is this blue one. So what you get at the end is them together, which starts here and goes to here. Well, that is 0, so none left to right, and 8 up. And you can kind of see this is how we break it down. One way we break it down visually is all we're doing is adding up the components for the, or 3 to the right and 3 to the left. Then if we add the two y's, it's 4 up and 4 up. So we get the same answer if we're doing it graphically by the tail to tip thing or algebraically. And we had better get the same answer, otherwise we did something wrong. So that's always a good way to check your work, is if you do something seemingly two different ways, but get the same answer, then both ways are correct. So this is addition, okay? what about scalar multiplication? So what did we say was true about scalar multiplication? So if we take some vector A and its magnitude is 2 and its direction is 45 degrees, then what is 2A?
$90 degrees.
So we draw A. We'll draw a little bigger. Given that, that is approximately A. What about 2A?
And
First of all, what is multiplication?
repeated addition.
Repeated addition. So 2A is also what?
2 times A, 2.
Well, that 2 times A, that's what 2A is. But what else is it?
A plus A.
A plus A. So if that's A, then that's A plus A. Remember, it's a new vector. It looks like that. So this is A and this is 2A. What is different about these two? Is there anything the same about these two?
They got a similar shape.
Well, they're both arrows.
They're directly proportional to each other.
Well, they're proportional to each other in what way? Or
They're in the same direction.
okay, so they're in the same direction. So what does that mean? Keep our color coding correct. It means that the angle did not change. But what did change? What does it mean to be in proportion to another thing?
Can you tell me the first letter?
A would equal 4. So
So
the magnitude is kind of different.
yeah. So if something is in proportion to something else, that means that you can multiply it by a specific number and get the other thing. So if you have 50% stake in the company, then your proportion of profits should be 50%, because you take whatever other thing you have and you multiply it by the proportion that's yours. So scalar multiplication has this quality. It makes the magnitude bigger or smaller. You multiply the magnitude by whatever the number is. And then you, I'm sorry, I'm a little high on cold medicine today, so give me a little bit of a pass. So when you multiply it by a scalar, the magnitude goes up and the angle does not change. There is one difference, and that is if the scalar is negative. Now, what happens if you multiply a vector by -1? I'll do this down here in green.
The vector goes in the opposite direction.
Yeah. So -a, what is the magnitude of -a?
-2.
No, because the magnitude can never be negative, ever.
2.
It's 2. It's still just as long, but what changes is, like you said, it flips to the opposite direction. So what is the angle?
-45.
No, and it's not -45 either, which is what you might think.
Is it 0?
It's not 0. So if that's a, -a would look like this. So if this is 45 degrees, then what is that angle?
Is it 135 degrees?
No, we're getting closer though.
Is it 225?
225. How did you get 225?
The unit circle?
Okay, what about the unit circle?
I think you said it's called like coterminal angles or something like that.
Not quite. So coterminal means that that the angle is effectively the same. So a coterminal angle would be that angle plus 2 pi. So with coterminal, the idea is that this angle is the same as this angle. These are, it's not even quite complementary angles, but let's look at it this way. what is the angle between that and that?
What?
What?
180 degrees?
180. Yeah. So if it's pointing the opposite direction, that means it's a straight line, you know, that goes on top of both of them. So the angle between this side and this side is 180. So the way you figure out whatever the angle is for the other one, it's that angle plus 180, which in this
So
case,
they're called like supplementary angles, right?
I think, I'm trying to think, supplementary, because complementary means they both add to 180. It could be supplementary. You might be right. Let's double check. No, supplementary is two angles whose sum is 180. Okay, no, so I was wrong. Supplementary is when you add them together and they are 180. Complementary is when you add them together and they are 90. So this is neither. Is as ridiculous as that sounds, I guess. But these are just, if you add 180 to one of them, then no. I'm trying to think, if you use the negative one, would it be negative? No, not even then. Yeah, I don't know. I'll have to look into that. So anyways, theta equals 220. Okay. So this is what happens when you scale something up or you make it negative. And you could do both. You could multiply it by like -2, in which case the magnitude would change and the angle would change. But let's see what this looks like algebraically. All right, so let's take a vector. Okay. So let's just say equals 4, 4. How do we find the magnitude of A?
By adding X and Y value?
Technically, but not probably the way you think. Technically, it is called adding them in quadrature, which is the big fancy name for it. Somebody else have an idea?
Yeah, is it the formula? I think it was like r squared equals rx squared plus ry squared.
Yeah. So that's what adding in quadrature means, is that the magnitude squared equals each component squared added together. So the magnitude equals square root of 4 squared plus 4 squared So what's 4 squared?
16.
What's 16 plus 16?
32.
And so you could say square root of 32 or 4 square root 2. Up to you. Both are correct. Okay. How do we find the direction of
Based off if it's positive or negative.
so how do we find the angle of this vector?
R times sine theta or R times cosine theta.
Yeah, so that's the equation you use. But if you're solving those equations for theta, what do they look like? So theta equals
The sine of
sine
RY.
1 of,
RY over R.
yeah, so or cosine of AX over A, or inverse tan of AY over AX. Okay. So there's a lot of stuff going on here. And remember, this is where it can be tricky. You have to think about where does this point exist in the 4 quadrants? So which quadrant is this in?
The first quadrant.
The first quadrant. Yeah. So the first one is kind of a lucky catch-all. If your thing is in the first quadrant, then any of them will work. The issue comes is if it's in one of the other ones. So for this, what is my angle? You can probably figure it out without even having to do any math.
$45.
45. Now, did you plug that into one of these equations, or was there something else that clued you into that? You can be honest. I'm not trying to mess you up. But if you had the alternate version, I was going to ask you to share it with the class. So we have some special triangles, right? What is one of the special triangles?
Right triangle.
Well, they're both right triangles.
45, 45, 90.
Yeah.
30, 60.
So 45, 45, 90. And the other one, I think you just said was 30, 60, 90. 45, 45, 90 has sides 1, 1, and square root 2. So any triangle whose x and y sides are the same is a 45, 45, 90. So because these two things are the same, we automatically know it's a 45, 45, 90. Okay, so Doing okay-ish on time. 2a. And figure out what this equals. So what did we say multiplying by 2 does to the vector? What does it change and what does it not change?
It doesn't change the magnitude.
It doesn't change the magnitude?
Does it don't change the angle or the
It doesn't change the angle. It does change the magnitude. What does it do to the magnitude?
Increases it.
Yeah. So in this case, the angle has to stay 45. And the magnitude changes by a factor of 2. Well, for the angle to stay the same, that means that the ratio of these two things has to still be the same. So that's if you just look at the last one, tan of -1 of a over x, or I'm sorry, ay over ax gives you the same thing. That means that ay over ax is the same amount. In this case, it's 1. But the magnitude is twice as much. So the way you do the magnitude twice as much is if each side is twice as big. So this is also why doing this way is much easier, because scalar multiplication is just something that we've dealt with before. It's 2 times the x and 2 times y. So this same thing holds true if you're talking about the negative thing. So negative a is what?
two times ax times 2 times ay.
No, that's 2a. These are 3 different things. If that's how you do 2a, what is negative 1a?
Is it just gonna be ax and ay?
That would just be a. What is negative a?
Negative ax, negative ay.
Which is
-4.
very good.
Oh, okay.
So this does not change the magnitude, because square root of -4 squared, -4 squared